Let's use the general formula for the probability of a union. We can use this general formula even if the events that we're interested in are not disjoint. The probability of A or B, let me make that or sign a little bit better. A union B, just like if it was a disjoint union, we would add their probabilities together because either one satisfying the condition of A or B. But then if there's some overlap between A and B, we need to subtract that. All right, so if you've got A there and B here with some overlap, and you find the area of A and you find the area of B, you've double counted that intersection. So you need to subtract off that intersection. Let's work through a few problems. A bag contains 4 solid blue marbles, 3 striped blue marbles, 3 solid reds, 2 solid greens, and 3 striped greens. All right, the probability of drawing a blue marble or a striped marble. So the probability of blue or striped, the marble could be blue or the marble could be striped, but maybe we have blue striped marbles that we counted twice. So we need to subtract off the blue and striped marbles. So the probability of blue, we have 4 solids and 3 striped blue marbles. So that gives us a total of 7 out of, I don't think we've counted the sum yet. There's 4 solid blues plus 3 puts me at 7, plus 7 puts me at 14. That's 16. And then the final 3 gives us 19. So 7 of the 19 are blue. How many are striped? Let's clear off the board. Okay, our striped marbles, 3 of them are blue and 3 of them are green. So we have 6 total striped marbles out of the 19. Now notice inside that 7/19 and inside that 6/19 are the 3 striped blue marbles, right? We double counted those. So we need to subtract off the 3 out of the 19 striped blue marbles. So when we do this, we get 13/19, or roughly about 68%, 0.68 or 68%. All right, the second question, the probability of drawing a red marble or a striped marble. So probability of red or striped will be the probability of red plus the probability of striped. And then we need to subtract off any red and striped marbles, right? Or red intersect striped marbles. All right, how many reds? We've got 7 red marbles. How many striped? Well, we actually already figured that out. 6/19. Or rather, there's 6, and the probability of drawing striped is 6/19. And we need to subtract off the red and striped marbles. But if you look at your red marbles, all of them are solid. So the intersection of red and striped is trivial. So this is truly a generalization of the equation for the union, or rather for the disjoint union, right? So this equation is always going to work for union probability questions, even if they are disjoint, or sorry, even if they're not disjoint, like in the first case where we actually had to subtract off the intersection, if you use the same equation when they are disjoint as in this case, the intersection is just 0. So you end up with just the sum of the probabilities. That reverts back to the equation that we gave ourselves for the union of disjoint probabilities. So when we go through this, 7 plus 6 gives us a 13, and 13 out of 19 gives us, oh, oddly enough, it's the same as the previous problem, 68%. Huh, that was not on purpose. Okay, let's work on this third one. The probability of drawing a green or striped marble. So the probability of green or striped, hopefully you can predict the equation now, probability of green plus the probability of striped minus the probability of the green striped marbles. All right, we have, let's clear off the board so we know what we're talking about. All right, how many green marbles do we have? We've got 2 solids and 3 stripes for a total of 5 out of the 19 that meet the condition of being green. How many striped marbles do we have? We've already figured that out. That's 6 out of the 19. And we subtract off the green stripes. There are 3 of those. All right, when we go through this, 5 plus 6 puts us at 11, and then minus 3 gives us 8. And 8/19 is going to give us 0.42 or 42%.